So this is the limit definition of the derivative. The derivative is when you take the limit as h approaches 0 of the difference quotient. That's what that's called. If you recognize this form, you can just take the derivative. That's what that means. Or you could use L'Hopital's rule to actually evaluate the limit. But this is the limit definition of the derivative. We could have f prime evaluated at some a value. That would be just the same thing. H goes to 0. You would just replace x with a. And that's the type of problem that you have. So here, so that also means the derivative. We could actually also have the limit as x approaches a. That would be f of x plus a minus f of x, I think. And this would be x minus a, or a minus x, or whatever. I don't actually remember. Actually, this bottom one is not. It was f of x. Let's erase this. There we go. So this is f of x minus f of a. Yeah. All right. So, and this is actually also f prime of some value. So we have some is like this. As x approaches a, then f of x approaches f of a, so that top becomes 0 and the bottom becomes 0, and we get 0 over 0, so we have to do some fancy stuff. All of this means a derivative. Here, it's like you're taking the derivative and you're not evaluating it at a certain number. For the bottom two, it's like you're taking the derivative and then plugging in a number. What you have is this situation right there. So we have, if you just remember this form, which you definitely should, because it'll be on the AP test. They always have at least one of these for the multiple choice, and it's really, really simple if you just remember this. So you could just know that, well, on the inside has to be an a plus h, so a is 1/2, a is 1/2, and that means f is everything else. So f is 8 something to the 8th, so 8x to the 8th. And we're plugging in 1/2. So this is actually saying what is f prime when you plug in 1/2, and f of x is 8x to the 8th. So take the derivative. F prime of x, that's just 8 times 8 is 64, x to the 7th. And then we have 64 times 1/2 to the 7th. Well, 64, what is that? That's 2 to the 4th is 16. 64 is 2 to the 6th. 2 to the 6th. And then divided by 2 to the 7th, right? Because I can put that on the inside. 1 to the 7th is just 1, so this is actually 1/2. There you go. That's easy. Or you could use L'Hopital's rule. Take the derivative with respect to h. But I think you might have to do that a couple times, you know. Because here we take that derivative, and it's nothing. That goes away. Oh, maybe you wouldn't. Take the derivative here, you'd get 64 times 1/2 plus h to the 7th, right? And then h is going to 0. Okay, great. And okay, yeah, times the derivative of the inside, the derivative of h is 1, and then times divided by that derivative. Yeah, you could use L'Hopital's rule as well. This would be, as h goes to 0, it's 1/2 to the 64 times 1/2 to the 7th, which is what we had. 64 times 1/2 to the 7th, which is just 1/2. All right, see you later.